All right, we are on 6.4. We're going to do 6.4 over 2 days. So first of all, we're going to start with, in this section, we're going to study a third vector operation called the dot product. When we do the dot product, it gives us a scalar. It does not give us a vector. And when we do the dot product, dot u times b, what we do is we multiply the first options and add it to the second locations, much like we do with matrices. The properties, I'm going to have you copy that from the book. So when we get to example number 1 here, and it says find the dot product of these, you take the first and the first location, multiply them, and add them to the second places multiplied. So together we get 17. It's an actual number. So on this, try the next two on your own. Go ahead and just pause the video, and when you come back, I will go through them. All right, you should have gotten 2 times 1 plus negative 1 times 2, which is 2 minus 2 for 0. And on the next one, you should have got 0 times 4 plus 3 times negative 2 for 0 minus 6 for negative 6. Note that the dot product of two vectors is a scalar, meaning it's a real number. It can be positive, it can be negative, or it can be 0. All right, so here I have a u vector, a v vector, and a w. We want to find the following: u dot v times w. So this is a dot product, and this means a multiplication of that dot product. So we're going to take u dot v, so negative 1, 2, plus 3, negative 4, which is going to be negative 14. Then we're going to take negative 14 times, because that's the scalar, and that's what a dot product gives me, times w, which is what we got in the last set of notes, which means we just kind of distribute it to get negative 14, 28. So u dot 2v means that we're going to take 2 times v, which would give us 4, negative 8. And now we're going to u dot this new vector. So negative 1, 4, plus 3, negative 8 gives a value of negative 28. The dot product of u with itself is 5, which is also the length of u. Keep in mind, when we say length, we're talking magnitude. It's that doubled bar symbol. So if I know u times u is 5, and from the properties that you copied down on the front page, you get that u dot u is the magnitude of it squared. So the magnitude of u must be the square root of 5. All right, the angle between two non-zero vectors is the angle between 0 and pi. This angle can be found using the dot product. Okay, so we're going to use this with our cosines. The cosine of an angle is u dot v, the vector dot product, divided by the magnitude of u times the magnitude of v. So we're going to use example number 4 to look at that. Find the angle in degrees, so that means we're going to be using this cosine, between these two vectors. If you wanted to look at a quick picture of this, 4, 3, so 4, 3 is u, 3, 5 is v. So what we're trying to do is find the angle between u and v. And when we're trying to find the angle between two vectors, so this is different than what we did in the last section. That was finding an angle from a horizontal. This is an angle between two vectors. We're going to use this formula. So here we're going to get the cosine of theta is the dot product, so 4 times 3 plus 3 times 5, divided by their magnitude, which is each piece squared, so 4 squared plus 3 squared, or their distance, and times 3 squared and 5 squared. All right, so that gives us 27. And when we do our calculations, this is 16, 9, 25 for 5. This is 9, 25 for 34. Or if we simplified it, we get 27 square root 34 over 170. We don't necessarily need to worry about that because remember we're trying to find the angle. So the angle is inverse cosine of that, which is approximately 22.2 degrees. All right, take the formula for the angle between two non-zeros, and we're going to rewrite it. So our angle, our current form of writing it, and what we're going to do is we're just going to solve it for the dot product. So if I had the dot product, it would be equal to the magnitudes, both of them multiplied, times the cosine of my angle. All this is just another way to do the exact same thing, but perhaps this time you're looking for the dot product. Maybe you know the angle. So it's just another way to look at the same thing. So from this, you can see that the dot product is actually equal to the dot product and cosine will always have the same sign. And the reason for this is because the magnitudes are always positive. Okay, so there's 5 different ways that vectors can go. Vectors can go in opposite directions. Here's their start point. They're going in opposite directions, which means theta is pi, and the cosine of theta is -1, because the angle here is 180 or pi. Therefore, the value of cosine is -1. Okay. Here we have our theta. if we look at our angle, it's clearly over 90 degrees. Therefore, we would say our angle is between 90 and 180, meaning cosine of my angle is between -1 and 0. In this case, we say the vectors create or form an obtuse angle. On number 3, hopefully we can see that the vectors are forming a right or 90-degree angle. That means theta is pi over 2, which means cosine is 0. In option number 4, the vectors are forming an acute angle. So there's my acute angle. So that means my angle is between 0 and 90, which means cosine of my angle is between 0 and 1. All right, our last option, this whole thing is u, meaning the vectors are in the same direction. So my theta angle is 0, therefore my cosine value is 1. And those are the only 5 ways that vectors can be formed: opposite directions, obtuse, right, acute, or in the same directions for 0. Definition of orthogonal vectors. The vectors u and v are orthogonal if their dot product is 0. The term orthogonal and perpendicular mean essentially the same things. They meet at right angles. Something I want you to put in here is if they were parallel, the u vector would be equal to some multiple of the v vector. So in example number 5, are the vectors u and v orthogonal? What you have to do is find their dot product. Is it 0? Is it just a multiple of u? Or is it neither? So here when I go u dot v, that would be 2 times 6 plus a -3 times 4. So 12 minus 12 is 0. So yes is the answer to, is it orthogonal? All right, so that's where we're going to stop for this first set of notes, and then we'll come back and do the second set another time.